first step of your flake project, measure 36 inches from both sides. Make sure you double check your measurements to make sure that you have 36 inches on both sides. You'll see that you have two lines, 36 inches off the left side, 36 inches off the right side. Between these two lines is scrap, so you'll be cutting twice. To cut the material as a refresher, you want to bring the saw all the way out. We want to hold the power trigger, push the saw down, and then towards the back of the fence. Let go of the power trigger, but control the handle until the machine is off. Then bring it back up and start in position. Bring it out. And bring the saw off. I'm going to turn around, line up the laser light with our mark, bring it out, start it up, down, and through. You can see that little piece of scrap in there. That's why it's so important to keep the saw down while it's winding down, then bring it back up. Not sure where that's going to go. Now you have two pieces that are 36 inches. Time to move on to the table saw. When using the table saw, we want to make sure that we have both faces flat. In this case, they came flat when we purchased them. We also want to make sure we have at least one edge flat. One face to ride flat on the table, one edge to ride flat on the fence. We're doing the operation called ripping. When you put your material tight against the fence and use it as a guide, we are going to push towards the fence, but yet forward through. We have push sticks ready to go for when the material gets a little too close to the blade. In order to transition over to push sticks, that if they get damaged, that's okay. When we slide it through, we want to make sure that we don't use push sticks right away. I have one hand supporting the material on the left side, and one hand forcefully using on the back side. If I start out with push sticks, I don't have enough control of the material, but I will have enough control with my hands. So now I'm going to put it away from the fence and just simulate how my motion should go through the process. Once I get the material on the surface of the table, so where I'm standing I can see part of the table, I'm going to transition my right hand with a push stick and go right in between the fence and the guard and push all the way through past the blade. Now out of view I do have a roller there, and then I can let go and reposition the push stick to have my good piece separated from my other piece, and I'm ready to go for another cut. Once I get close to the blade after cutting all my pieces, I will be using this push stick to push my last piece of scrap to the side of the blade. My measurement for the flake project is going to be, the material is going to be ripped at 1.5 inches. To do that, I bring the fence over and I'll be able to look through the little window and push the handle down, locked in at 1.5 inches. On the left side down, there's a small little paddle on. I'll pull that on and start my process. Now my last piece is kind of small. So I'm going to use both push sticks. Start with my hands first and replace one push having one hand on the material. Stop, replace one hand, replace the other hand, push all the way through. Stop, push the paddle in. After you have all 13 boards cut to your 36 inches, it's time to nitpick and figure out exactly what your pattern should be. You can flip over your boards. I like the knot in there, the open knot, so I'm going to keep that in there. There's other knots and defects in the material. There's also stamped from the manufacturer, and sometimes there's going to be a split or check or warp that you might want to work out. After you have your pattern established, it's time to mark off where your blue field of the flag is going to be and make sure everything is 90 degrees. Just insight on exactly why I chose the pattern that I did. I like the knotty pine look, and each one of these, we start with blue and red. Then we have blue, white, but what will be just the bare material. So each white stripe, I left some of the knots in. So I kind of alternated each one of the reds because most of it's going to be covered up. Not a lot of grain or knots are going to show through. I just kind of kept those in the clear. So that was the reason for my pattern. But it should still fairly be random. This area here, the field, is going to be blue, and we are going to CNC route each of the stars in that field that I don't want any knots in here, just in case it looks a little discolored or a knot chips out. I want to keep that area clear. So really take your time with setting up your boards. Once you are complete with all 13 boards, take your framing square and square up, preferably the left side. If the right side is off a little bit, we'll always be able to cut or sand that near the end. Once your boards are 90 degrees, we're going to take our tape measure, or you could also use your framing square to mark 13 3/4 of an inch from the left side. Now notice I only marked one board. Since I have my framing square, and once again you can measure 13 3/4, I'm going to use my framing square to mark every single board at once, which is more efficient. 1, 2, 3, 4, 5, 6, 7 boards should be marked for the field. So I'm going to stop at that 7th board, and there's my field. I'm going to move these boards, and I'm going to use razor blades, and I'm going to stamp the razor blades in that line. After you've marked your lines, we really need to make sure that all our pattern stays the same. So if there's an unfortunate no where we have to clean up and discontinue our work for the day, that when we come back to revisit that we're not spending a lot of time. So labeling is very important. What I want to do is flip each one over exactly the same so my field stays here and all the rest of my knots and everything stay where they're at. The other thing for labeling also is that when we're connecting everything, we want to make sure that when it's flipped face down, that we have everything correct and it's not flipped around upside down and backwards. So I'm going to flip each one of these over from the left side and flip it to the right. So we're putting them face down. It may not seem like it matters with all these boards, but you have already established, we put those two down. You've already established the pattern. So now my field is going over there, but when I flip it around, it is going to be facing the correct way. So there's my board, my flag face down. So I'm going to mark each one on the left side here, or what is now the left side, but when I flip over, it'll be the right side. 1, 2, 3, all the way up to 8. If you would like to sand that off later, or it doesn't matter, it's on the back side, but we need to make sure that all those numbers now are lined up. So when it's face down, we know that our field is in the correct spot and all the stripes are in the correct spot also. I moved my 7 pieces that are going to include the field of the flag onto a harder surface table. What I'm going to do is, right at the line that we took, I'm going to take a tweezers and hold a utility knife blade and pound right on top of the line. What this is going to do, and you can see these razor blades have been used quite a good amount of time, and there's blue on one side mainly and red on another side. So when I stain this area blue anywhere in the field, it will stop the stain from going into the white or red part of the field. Continue this process until all 7 are covered, and then we'll move into the stain room. All my material now that has a need for the field and the stripes separate, I have the utility knife blades pounded in. Typically in the finishing room we have boards, scrap boards that are nice for transportation of things that have a lot of pieces. So if you recall, I labeled the pieces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So on the back side, I still have the numbers, so I'll know exactly which one starts with blue, red, blue, white, and so on throughout the process. I even want to take these in here because part of them are going to have the red full stripe and the other one's bare and probably should just travel with the rest of the project. Welcome to the finishing room. Our finishing room, we want to make sure that the fan is on. When the ventilation is turned on, we want to make sure that our first board is stained blue and red, blue and nothing, blue and red, and so on. When we get to the red, 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 we skip this board and put it off to the side. Since this board, nothing is going to be done to it, we're going to lean it up. Same thing with the next board. And our next board. And then we'll know that we continue with just these 3 boards, red. The cans themselves, what we did with a brand new can is take a framing nail and penetrate the rim. Just a light tap with the hammer. And the reason why we do that is to make sure that when we dip our brush, and if wiping the brush, anything comes out into the rim, it'll seep back into the can, preventing a buildup in the rim of the can. We use a basic chip brush to apply our stain. Once you're complete with the staining process, you want to go back over the stain and wipe the excess off. If you choose to leave the stain set That's up to you. It's a preference. I have 2 different small, just scrap cotton rags. And I'm going to carefully wipe the excess off. When setting the lid back onto the cans of stain, you can see once again one of the reasons why we tapped holes into the rim is to make sure anything would seep back. However, we want to make sure that nothing splatters out of the rim by covering it with a rag. In this case, we'll use our rag that we used to wipe the red stain on the red can. We also want to make sure that we don't hit the middle of the can. All this will do will dent the can and will not give a good seal. We want to tap nice and light around the outside of the can where the rim of the lid is, not in the middle. And it doesn't need much to seal. After the staining process is complete, bring the project out of the room so other people can use the ventilation to area. We're going to use a lockjaw pliers to remove the razor blades. Although they're not in the material deep, they are sharp. We don't want to grab onto them and slip with our bare hands. Please let your project totally dry until the next class period. For all the pieces to connect, we're going to cut 2 pieces that were a little narrower. With the rest of the boards, some of them got ripped down and there were a couple narrow pieces left. Those are the pieces we're going to use for the back. We're going to put one in the back, a few inches in from both sides. First thing, we're going to measure out the approximate center to mark each mark 5/8 in from each edge. I'm going to use the other piece to just draw a line straight up and down. Unfortunately, we don't need the screw holes accurate 100%, so we can sacrifice by doing a fair guess on the center. I also cut these pieces a little shorter than what they really need to be. I have 13 pieces at 1.5 inches. 1.5 times 13 would be 19.5. I had to cut my pieces to 19 1/4, just a little shorter than what would have been 1.5 inches for each piece. Very well may have been doing the drying of the material, shrinking, and so on. Now that I have my pieces marked, I'm going to mark the about center of each of my 1.5 inch stripes. From there, I'm going to countersink each of those marks with a number 6 countersink and use 1.25 inch screws. I'll need 26 1.25 inch screws to accommodate all the holes necessary for the flight project. The reason why we use 1.25 inch screws, we have 3/4 material, 3/4 material. When we put a screw in there, as it's countersunk, it won't penetrate the front side of our flag. Our countersink bit is equipped with a 7/64 bit. That is just a bit smaller than our 1.25" number 6 screw. You'll see that I'm going to leave just a little bit left for the screw to penetrate the material. The screw will also have enough thread grab into the wood material by using our 7/64 bit. We're going to go all the way down to this collar here, and you can see it'll accommodate the head of the screw, but not penetrate the front of our flag. Our particular drill is a keyless chuck. If I have the drill in reverse and hold the chuck and pull the trigger, you'll see it open up. If I put the drill in forward and hold the chuck, you can see it close. Reverse, open. When I put my bit into the chuck, it's going to be very loose. Now I'm going to put it in forward and cradle the bit while I'm holding the chuck, and ever so slightly hold the trigger down so it's nice and loose. Once it grabs on, you can hold the chuck a little tighter so the bit is secure into the keyless chuck. There's different settings on the drill. You can see that there's a little drill bit and an arrow lined up. That's what we want. If we turn the torque setting to a different number, such as a 3, and hold the chuck while it's in forward, you'll hear it start to grind. That's specific for other operations depending on the type of fastener and materials that you're going through, so you don't go continuously through. We're going to keep it, since we're doing drill, we're going to keep it at drill. When using a hand drill, we want to make sure that we always have a backup board available. A backup board is going to prevent us from drilling into the table or into our project. If I were to drill one of these marks on my board, you can see that the bit, once stopped at the collar, will penetrate my material. I don't want to drill into the table, and I don't want to drill into my project. So I'm going to use the backup board, line it up, and drill straight in, rock it through, and bring it straight out. The bit will create friction, so we want to make sure we don't touch the bit. It's going to be hot. There's my countersunk hole. Once again, to accommodate the head of the screw. You can see it did penetrate the other side, and it also penetrated the backup board, but did not go all the way through. Using a backup board will protect our table and our projects. I'm going to complete the rest of the holes on both pieces. When lining up the boards for fastening, I'm going to flip my boards so I can identify exactly the 1 through 13 numbers I previously marked on the board. There's 13. Make sure you're numbering 1, 2, 3 all the way through 13, and make sure all those numbers are in fact reading the same way, so you don't have a white one flipped over even though both sides are bare. I'm going to just take a straight edge and line these areas up. This area right here face down is my field, so I want to make sure these are pretty darn even. Make sure my line in the middle is fairly even. I'm going to mark my board 2 inches, top and bottom. I'm going to keep my material that I drilled all the holes in to the inside of that 2-inch mark. I'm going to bring my material over to the edge. There's a lot of gaps that that are forming in the middle of my board, and that's okay. Don't worry about that just yet. We're going to take it one side at a time. One of the first things we want to do is clamp our board that we're going to screw to the back of our flag. Clamp that down to the table, not just to the back piece, and make sure it doesn't sear off of that 2-inch line. The clamps that we're using are quick grip clamps. They're just like bar clamps, but are only the strength of what you can squeeze. Our other clamps, our parallel wood screw clamps or other bar clamps, would work just as fine. These are just fairly convenient. Although I'm covering up some of my holes, that's okay. Now that I have all these areas here flat, I don't have to worry about any of this yet until I get to that side. I want to make sure that everything is fairly tight this way. Having these two clamps down here, I'm going to need a third one to squeeze just a little bit, but not too much. So my pieces don't fold up on each other. You can see the gaps close up. Now as long as I can get a few screws in here, those will stay, and then I can open it up for my other clamps. The bit that I'm going to be using to drive my screws is a number 2 Phillips. Put it in the countersink and lightly until it reaches the surface and just below. Have faith in the 1¼ screws, not penetrating through now 1.5 material. It's time to move over to the CNC route. On the desktop, select the Velocity CNC 4 by double-clicking on the icon. Select Connect for the Velocity CNC. Agree to the safety terms. We'll be focusing on the jog button. When you select jog, you can move the CNC router in -Y, +Y, -X, +X, -Z, and +Z. You'll notice when you hit the positives that the numbers X, Y, and Z move up. When the negatives are selected, they move down. If I have this currently on slow, if I have the speed at medium, the numbers get greater or smaller quicker. Moving over to the CNC router, you can see if I hit the -X, that the CNC router moves into the position of -X, +X, -Y towards me, +Y away from me. Z is up and down. This you want to be very careful with because you don't want to move fast into the material. And there's +Z away from the material. We also have to watch that we don't go too high or too slow. There are stops in the machine. There are red stops on the front side and the back side of the CNC router. These are for the Y position. If I select fast and move in its -Y position, you'll see that the CNC router moves fast. And we want to make sure that the bracket does not hit the red bar. let's do that again. I want to make sure that the bracket doesn't hit the red bar. In the X position, I'm going to select -X. We want to make sure that the CNC router doesn't hit this bar with full force. -X. +X, there's one also on the other side. For Z, and it's very hard to have something this thick, we do not want the top bar of the CNC router to reach anywhere near this bar. So we'll stop before it hits. In our -Z, we want to make sure that the bit doesn't hit the table. Rarely do we use the fast during this operation. If we slam the bit into the table or into our material, it could do heavy damage to the CNC router. Safely practice the positives and the negatives of the CNC router. Get a feel for medium, slow, fast, but if anything, we want to stay closer to the slow, especially when we're setting up our piece. So we're going to get the bit very close to the corner of our piece, but after you're done practicing, we want to move the CNC router away from our lower left area of the table so we can line up our wood flag. 1. Just on the opposite side of our CNC router, we have a lot of boards here that are perfectly square, perfectly 90 degrees. We also have some 1 1/4 screws that you will see throughout the course. We're going to use these construction screws and the wood to line up our flag. When you grab a few boards, one of the things I like to do is use the edge of the CNC router. We know that this is in perfect alignment with our bit, and the boards are perfectly 90 degrees. Regardless of which way you go, and in this project, I'm going to put the boards kind of running a little bit more widthwise and about the size of our flag, about that 36 inches, and maybe in a little bit, just to kind of leave some of the corners open. These boards, I'm going to screw down to our sacrificial table. And as to not have a pivot point, I want to use 2 screws per board. Now that these boards are fastened in, this is specific to our flag project. If you recall, on the back side, we had all of our boards screwed together on just those 2 boards. So that's going to build up the thickness just a little bit. So once we get these first boards in, we're going to put our field in this area. And eventually we're going to take this point as our 0, point. Now because the boards are 3/4 thick and our full flag is now 1.5 inches, you can see that it's going to slide right underneath. So we want to put 2 more boards very flat and very even with our 2 end boards. Fortunately, the boards that we have are the same size. We're going to put these up to the side of the CNC router also. Put 2 screws in. Once again, the boards themselves, no rhyme or reason to where we put the screws. Now that we have those 4 boards in, 1, 2, 3, 4, 2 screws apiece, now we can put our flag tight against those boards. Now, we'll still move if we don't fasten our flag down. To do that, we're going to put 2 more boards up there, 2 more boards on this side, and 2 more boards on this side. Fortunately, we can put these boards underneath, and it really doesn't have to be that perfect when it comes to alignment, because those boards are just going to be holding the boards that actually hold the flag in place. I'm going to move the CNC router up in positive Y a little bit more. Then I'll be able to access the back side of the flag. One of the boards that you pick out, or if you don't, we'll countersink some holes and we'll do them at an angle. When I put this board in here and I put the screw at an angle, it's going to squeeze the flag tight against those first 2 boards. Hopefully, we're able to see that squeeze. So now the flag will not move. If I pulled really hard on it, I could still move it this way. So I'm going to put 2 more boards right at the front side of the flag. Our goal at this point is to point the bit right at the tip of the field. And then we'll set that for 0, 0, 0. That will be our 0 point when we run all the stars. And move our router all the way down. Now I'm going to start detailing, and I'm going to select medium. And I'm going to select down in Z. You do not want to get too impatient and select the fast, especially when you're doing a negative Z. Now from my view, I can see that I'm about 1/4 inch off of the surface. I'm going to hit positive Y to move it over to the right. I'm going to hit negative Y to move it a little closer, and then another negative Z to move it down closer. Now you can see the bit and how close it is. I'm going to select negative, X, and you can see medium jumped a little too quick. I'm going to select the slow button and positive X. Negative Y, and negative Z. Once you feel like you're right on the corner, take a piece of paper, slide the piece of paper underneath the bit. If you can feel friction, then you're okay. Through that process, I manipulated the X, Y, and Z in both positives and negatives for each. The X, I ended up with an arbitrary number of 0.2269. That means nothing to us. Y, negative 3.2499, that means nothing to us. And Z, 0.8560, means nothing to us. What does matter to us is where the bit lies now. That is our 00. That is my 00. Depending on the boards you pick and how you connect your flag to the table is going to be up to you and what you come up with for your 0-0. The bottom line is to get that bit using the fast, medium, and slow X, Y, and Z jogging to that corner. Once you're complete, you hit the set button at the top of the X, Y, Z program coordinates and you set all to 0. Set 0 all, confirm by selecting OK. The most important part of this operation, understanding your X, Y, and Z now set at 0, is your point of your corner of your field of your board. This will be the same process with any CNC project. That's the 0-0-0 we just set. Once you're done setting the 0-0 in the lower left in relation to the CNC router's X, Y, we need to take this point, X, Y. So now our velocity CNC router is set 0-0-0. We're going to raise up the Z a little bit and jog until we meet this point. Then we're going to lift up and put it back to 0-0 after we get this measurement. So I'm going to move medium up positive Z and fast positive Y and positive X. I'm going to move medium. It looks like a little bit positive X, maybe a little bit negative Y, and slow negative Z so I don't puncture my board. And I need to move up a little bit, positive Y. And I don't necessarily have to get the Z directly on. I just need to know where that point is in X, Y for my design. The previous setting was 0-0-0. These two numbers are the numbers I need to enter into my design. On the desktop, open up the American Flag Stars VCarve Pro 9.0 file by double-clicking. You can see the stars are positioned. Way down here, my 0-0 is the very lower left. Up here is the blank space on the CNC router. I'm going to toggle back and forth between my CNC, Velocity CNC router, and the software. I'm going to zoom up into this area. I already took my 0-0 and I know that this is going to be the starting point of my flag. Right here in the X, Y, this is considered my upper right. I know the flag orientation is a little bit different, but this is the point that I need to be worried about so my stars don't go out into the stripes or take too less of the field. When I go back into the Velocity CNC, I can see that my measurements will be different than yours. I have 10.2511 in X. If I drag a guideline out of the left side by simply clicking on the ruler and dragging out a line, and I can drop it anywhere. If I hit my right mouse button on that line, you can see the coordinates pop up. Currently, the position is 12.5 inches. My new position is what the Velocity CNC router is telling me, which is 10.2511. If you forget this measurement, simply toggle back to the CNC router. 10.2511. 10.2511. My number lock was off. 10.2511. Select apply and close. I'm going to zoom up and you can see where my guideline is in relation to where the original design box is. So I have to move my stars a little bit smaller to accommodate that lost space. I'm going to zoom out by simply wheeling the mouse away from the screen a little bit. I need to take my Y measurement. In the same manner of clicking, holding, dragging out a line to position it in X, I need to drag a line out horizontally to position it in Y. Click hold with your left mouse button, drag out a guideline. Hit my right mouse button, the new position of that guideline is going to be what the Velocity CNC router tells me, 14.2442. 14.2442. Once again, your number may be different. Select apply and close. You can see this is very important because where my corner is significantly different, and my stars would be too close if I did not shrink this area. To do this proportionately, I'm going to highlight my stars and the red box by doing a very large, oversized drag over both of them. I'm going to single left click on the box. I'm going to zoom up in the corner, and I'm going to drag towards that corner. If I drag larger, you can see everything gets larger. If I drag smaller, you can see everything gets smaller. I need to drag up to this corner, and you can see now I'll have enough space on both sides to accommodate the stars. I'll also have enough space, and if I wanted to move everything over just a little bit more, I have a little bit of space. So I'm going to highlight everything and just move it over just a little bit by clicking, holding, and dragging just a little bit so things are kind of evened out. Fortunately, this is a rustic flag and you don't have to be perfect. I'm going to minimize the V-carve and come back to my Velocity CNC. I'm not even going to watch the actual bit. I'm going to watch my screen to make sure, because this is even well less than 1/16 of an inch. I'm going to go not slow, but maybe medium, positive Z to move it up a little bit. And I'm now going to move the router all the way back to 0, 0, and 0 by not even watching the router itself, but watching these numbers. So I know I have to come back in negative X, 10.251. If you go a little too far, that's okay. You can select the positive. I'm going to do the same thing for Y and Z. So in X, I'm going to go fast, negative X, until I get close to 0. Y, negative Y, fast. And I'm just going to tap a few times to get closer. I'm going to go medium, and I'm going to hit negative X a few times until I get even closer to 0. And you can see I went into negatives. Now I'm ready to load my G-code. In the upper right corner, you'll see a faint tab called Toolpaths. When you hover over, it will bring the toolpaths out. There's a small little push pin that we want to make sure that we can not auto hide it by pressing that push pin to keep our toolpath operations active. I'm going to click with my wheel mouse, or zoom with my wheel mouse, and show you the stars. What I want to do at this point is I want to pocket just the stars out. So I'm going to select Pocket Toolpath. I'm going to start from the top and work my way down. I do want the cut depth at 0.065. 0.25. Please do not type in anything else deeper because we're only going to take one pass. If you type anything deeper, it's going to really wear out the bit. The bit that we have is going to be a 60° and 1/4 inch bit. If this one isn't selected, hit select and select the V bit 60° 0.25 bit. Select OK. Offset and raster, depending on how you'd like to clear out the stars. I like the fancy swirl that gives us with the offset option. Please do not select ramp plunge moves. We are going to name this Pocket 1. And before we select calculate, we need to select just the stars. To do this, you could single click and then hold the shift key and single click on each star. If I left click in the blank screen, then they disappear. If you anticipate a window by selecting here off but not the full red line, because you do not want the red line in there, and drag the window over all the stars. So I started right here before the line and ended up here past everything. You can see that just the stars are highlighted. If you accidentally highlight everything, including the red box, restart the command and just select the stars within that window. Now you can select calculate. I'm going to zoom up on the preview and you can see there's the stars that will be pocketed out. If you'd like to see them in action before you actually print, you can select the play button and you can see how they're going to look. Granted, these are a lot more pixelated than what will show up on your board. Select close. Select the old school save disk and save your toolpath as Pocket 1. You're going to save the toolpath and you're going to save it on the desktop. And remember what you saved it as, Pocket 1. If you'd like to name it something that you would like to remember, but a lot of people are going to be saving as Pocket 1. So if you come back to the machine, you always want to run a new toolpath. In our case, we never want to run the same toolpath because our setup's going to be different for this particular project. Select Save. Pocket 1 already exists? Yes, we do want to replace it. Back in the taskbar, select our velocity CNC that's still set up at 0. And our bit, still down below, is still in the lower left corner at 00. Select File, open G-code. Our G-code is the pocket1.ncc. Select Open. And you'll see that the G-code populates and is written for us. And you'll be able to see the bit in its run form in 3D and in 2D. The red lines that connect all the stars are just the path that we will take on each star. In the lower right, we don't want to be in jog anymore. We want to be in the G-code and run it. Select G-code. The calculated runtime for this project is 23 minutes and 56 seconds, or 58 seconds. Select Start. If something happens, you can always select the feed hold by selecting any key, and it will stop the machine. Start. Once the CNC router is complete with the run, select the jog on your Velocity CNC and medium positive Z, fast positive Y, to be able to access the boards to unscrew to get your project out. If you'd like to make your flag more rustic looking, you can take it home and use a small propane tank with a torch to go lightly over the surface of the project. I would suggest that you practice on a scrap piece of material that's the same species, this being pine, and to make sure that you don't go over the project too hard or stay in one spot for too long. One of the very common errors for this project is to spend too much time in the star area, and the stars start getting very, very dark, and the field is also very, very dark, and then doesn't show up the stars, which are supposed to be white. So please go over it very, very lightly, but once again, use a scrap piece of material. To make your flag more rustic looking, you can take it home and use a propane tank and torch to lightly go over the surface of the flag with a light burn. If you choose to do the more rustic look to your board, please use parental supervision, and I'm using matte gas. You can use propane, but you want to practice on a piece of wood first, and I'm going to go very fast. You can see not much was done. A little slower, and you can see it starting to show the grain through a little bit more. A little slower yet, maybe too dark. So I'm about 2 inches away, so I'm going to bring it back just a little bit and go about that same speed. I'm going to practice on the other side. I would say quicker and closer might be better. And you can always take more passes, you can't take more passes off.